Hello, this is Jay from Density Fingerprinting. We have been getting quite a lot of responses about issues with figuring out how to use these two websites. They're brand new, and we understand people are having a hard time. Okay, so this is a short demo answering most of the questions. So first, I'm going to introduce two different websites here. We have Density Calculator and Density Fingerprinting. This one is our main one. Calculator is a helping hand. As the name implies, it's calculator for density of an alloy. Okay, so let me just go ahead with a random composition. So let's say I have an alloy of gold. We go silver because silver goes in gold, and then let me put in copper. Okay, and then I'm going to put in mass percent. Okay, let me pick some random numbers. How random can I get? 76. Okay. Okay, 76. Put in 15. Now this has to be 100 minus. So that's 9. And then the number of decimal places to round up, I'm just going to go with an easy 7. And this is my density. So we have a very straightforward equation to relate percent composition to density. And in this, you can expand it to however many metals you want, and you can by feeding in the mass percent, you can get the density pretty accurately. So I'm just going to copy this over. The difficult part becomes doing the opposite, having a density and figuring out what mass percents there is, because then it becomes an indeterminate system. Okay, so let me just go here. So in this website, you have to log in, but at the same time, you have to know that this is valid only for whole number mass percents, which is these being whole numbers. But if you have a composition which is in decimal, that's okay too. Please send this over to us and we will decode it and let you know the results. And that feature will be available in future builds of this website, but for now let's just go with whole numbers. So I'm just going to select these three metals, silver and copper. Okay, and then I'm going to paste in this density and hit calculate. So it will do the entire process, and I have a composition. So I have gold 76, silver 15, and copper 9, and it goes through all the lots. Alright, so let's see. So this is 76, 15, and 9. And check here. Okay, 76, 15, and 9. Okay, so it worked. And it decoded from this density what the mass percents were, and it also produced a range that the gold has to be from 73 to 80%. It cannot be over or it cannot be less. Same thing for here, silver and copper. Took 0.017 seconds to get this answer, and then it took further 10.7 seconds to plot this entire thing and tabulate it. So here you see 3 series, and in each series you can see this composition present as red. And this is the only composition that is common among these 3 series. That's how it finds it. Isn't that amazing? So when you do a plot, this common entity becomes very much apparent. You can zoom in. You can do all sorts of stuff in here. You can scroll to zoom, turn off series, turn on. You can download the graphs if you want to. Like for instance, you can download it in any of these formats. It will work. Okay, so it tells us for this density, these are the compositions, and you can see 3 series, and I have 3 different colors. These are my metals. So, and you can see they're all the same. This is the only one that has all 3 the same. The others have some difference. Alright, so now we are at the ternary plot. So it's 3 metals, 3 axes. We can plot them in here. And when we do that, you see all 3 different axes, all 3 different series having blue, red, and green color. They end up having a common point right there, which is our composition. So if I turn off these, keep your eyes here, and you will see there's a blue dot there, there's a red dot there, and also a green dot. They superimpose. And when we do a projection of this, you get a 2D graph. The reason for this is very straightforward. When you go into much higher number of metals, you don't have that many axes to work with, so a projection graph will do. So you will end up with a similar sort of superimposition here. Right, so all 3 of them are superimposed here. And this is how it does it. So this composition works here. Now let me try to go for higher metal, let's say 4 metal, and zinc goes in here. For gold alloy, zinc goes in. Okay, so let me try this. Let's see what this shows. And voila. So I have 76, 15, and 9 here, which is correct. And then I have 0 for zinc. Isn't that amazing? So it detected zinc to be 0, so it knows that it's a ternary alloy. That's the most amazing part about this system, is that it can detect whether your alloy is a binary or ternary or even pure metal, and it will produce zeros for the remaining compositions. So you see, for 4 metals based on NC2, you will have 6 series, and you see 4 of them here. If I scroll over, you will see up to 6, and you see the red composition, which is our answer, is common between all of them. Right? And this is the only common entity among these 6 series. And then when we plot this spectrum graph, you see right there. So you see the horizontal, if you're seeing the gold, silver, and copper ternary 3 metals, and they're literally the same amount for all 6 of these series. And if you go into here, now previously it was a ternary plot, 3 axes. Now we have 4 axes, so it ends up being a tetrahedral plot. And you can see this is a region, this triangle is a region where all the compositions are. And the arrow points to this composition that happens to be our answer. And you can see this composition is lying on this edge, and that's because it's a ternary. If it was a quaternary, it would be inside. Now here I can do the same thing. I can turn off these axes, and you can keep an eye on this composition. You can see all the points lie there. Right, so that's how it tells that you have the correct answer here. Now you have the same thing in here, projection. And if you want to zoom out, you can do a reset. And you can see along this line is this point. So projection of this is this. And it works out pretty well. Now let me go back to 3 metal. And let me do something interesting here. Okay, so let's say I have an alloy that is this density. Now, if you notice, this density is present here, 10.5. That's 100. So it detected that it was pure silver, right? And along with that pure silver, it produced all these different probable compositions as well. That will give you same density. So from this one density, you can figure out what mass percent there is. And if you're not sure what alloy you have, or like what metals to choose from, you can say, okay, I have a gold alloy, let's say. Then you can select up to 6 metals. However, which metals go into gold, they make an alloy with gold, and that way you can bring down the overall number of metals to maximum 6 on this website. Now here we're working with only whole numbers, as you mentioned. The decimal will be a future release, and for that you can select iterative step, and it will be 0.1, 0.01, so forth, and you can select that and it will give you mass percent correct to that decimal place. So another key thing to note here, so let me bring back the previous density. So if I bring in a lower accuracy for this, you see I got a different answer than this. So it is very much dependent on how many decimal places you have for your density. So let's say I have 3 decimal places in this case, and in 3 decimal places it does work. So 76, 15, 9, it does work. So when you go into higher metal, let's say 4 metal, 5 metal, and so forth, you will have to increase the accuracy. That's one caveat to this. But other than that, it is able to decode this one number into how many numbers you want. We're doing up to 6 metals. So that's pretty much it when it comes to utilizing the software. And as you can see, you can create wonderful graphs that tell you a lot more detail about your analysis, and you can download it if you want to for personal use, per application, and you can do these formats, and you can just straight up download. For instance, let's say I want to download this part, this view, so I can do the personal use, and I can do a simple PNG and download, and it will produce this graph, right? That's literally what this is. So yes, you have full customizability when it comes to graphs, and also have full control over whatever you want it to perform. And for convenience, we have also placed this website, this calculator, over here on the right top. You can see the calculator button, and you can utilize this right here. So you don't have to switch tabs or no need to do anything. You can directly go here, and then you can click outside and you'll be back. So that's pretty much it. I hope you enjoyed this, and if you have any further questions, let us know. Until then, see ya.